Good evening. I'm Dr. Darrell Boyd, the chemist, and I'm coming to you on behalf of the Transformational Education Adventure Center, also known as the T Center, which is located in McLean, Virginia. And I will be teaching a STEM lesson today. Today, our lesson topic is paper chromatography. Paper chromatography. All right. So the first word you may be familiar with, paper. We are very familiar with paper, but that second word, chromatography. Chromatography. What does that word mean? Well, that word has to do with the separation of compounds. All right. So we're going to use paper to separate something out. Here's what you'll need to follow along today. You will need a transparent container like a cup or a glass. You're going to need some water. You're going to need a coffee cup filter. If you don't have a coffee cup filter, you can also just rip off a piece of paper towel like I've ripped this piece off here. All right. And most importantly, you're going to need a black marker. All right. And the marker needs to be a washable marker, like Crayola black washable marker, like the one I have here. And you can see that it says that it is black. Okay. Now, it's important that we take notes because we want to write down what it is that we're doing. And so today, write down your topic. The topic is paper chromatography. And then write down everything that you'll need: a transparent container, water, paper towel or coffee cup filter, and a washable black marker. You want to write all that in your notebook. And then you want to write down today's question. And today's question is this marker really black? Is this marker really black? We're going to find out. But what do you think? Do you think this marker is really black? If your answer is yes, write that down. If your answer is no, write that down. Either way, your answer to that question is your hypothesis. All right? As a scientist, we always have a hypothesis, which is a guess we can test, or an idea you can test, or a prediction that you can test. So if you think this is a black marker, you're saying, I predict that this marker will be proven to be black after today's experiment. Or maybe not. Write it down. Here's what you'll need to do. As I mentioned before, if you're using paper towel, just rip off a piece of paper towel, and you will want your paper towel to be able to sit inside your cup or your glass like this. All right, just so you can see it. All right, that's how you would like for it to sit in the glass. We're not going to put it in there just yet. If you are using a coffee cup filter, what you will need to do is take the filter and fold it in half. All right, like I've done here. And then you need to fold it in half another time. All right, you end up with a quarter of a coffee filter like that. And then what you'll need to do is to take your marker and draw a black line about 1 inch from the corner of the filter. And I'll show you how to do that. All right, so you want to draw like that. Then you want to flip it over and do the same thing to the other side. Okay, so I have a solid black line from my washable black marker on the filter. Now, you do something similar. Oh boy, I kind of wet my paper towel up, so I have to get another piece of paper towel. I can do that. All right, I see that it will fit there. Good. So what I'm going to do here is I'm going to draw a black line parallel to the bottom, about 1 inch from the bottom, 1.5 inches from the bottom. All right. Okay, so this is what you'll do if you have paper towel. Now, what you want to do is take water and pour it into your container. Not a lot of water though. You don't need a lot of water for this. Just a little bit of water there. And since I'm doing both versions, I'm gonna do one version with the paper towel and one version with the coffee filter. Need a little more water for the coffee filter because you'll see in a moment that I need the tip of the coffee filter to touch the water. Now the goal here with the water is to not have the marker touch the water, okay? So I'm going to place this paper towel in the water, and then I'm just gonna observe what happens. And similarly, I'm going to, hopefully this fits in there. I'm gonna open up this coffee filter. Like this, and then I'm gonna place it in the water here. And then I'm gonna watch what happens. Now, one of the most important things that I can do as a scientist is to observe. Observe, meaning I need to pay attention to what I'm seeing. Okay, so as this reaction takes place, or as this process takes place, I'm watching what's going on. And if you want to, in your notebook, you can take notes. Write down what it is that you're seeing. Write down what is happening. All right. And writing things down is incredibly important for any scientist because we want to have proof of the observations. We want to have proof that something actually occurred, or sometimes nothing occurs. And that's important too. You just want to write it down. So this process will take a couple of minutes and we're just going to sit here and we're going to watch and observe. You can already see here with the paper towel that that line that was a black line before is turning into something that's not quite a black line anymore. And similarly here with this coffee filter, you can see that what was once a black line is turning into something other than a black line, right? Why is this happening? Why is this happening? Well, there's this concept, I'll write this word down. There's this concept called polarity. Polarity. All right, polarity is what we call the separation of charges. The separation of charges. That's polarity. Well, what does that mean? That means that some liquids, like water, have charged character to them, meaning they have positive and negative character associated with them. Also, the dyes in the marker have charges associated with them, or they're polar or have varying polarities. Water, because it is a polar molecule, if there's a dye that is also very polar, it will move up the coffee filter or the paper towel close to the water line because it is attracted to that particular polarity. It's attracted to the water. If it is not polar, or if it has less polarity, it won't travel to the top with water or close to the water. It may travel up slower because its polarity is less. Okay? So, based on what I'm seeing here, it appears that first and foremost, that question I asked, is this marker really black? It looks like this marker is not black. It appears to be a mixture of dyes that gives us a black color. Okay, so it looks black to us when we write with it. But if I were to separate it out like I have done here using paper chromatography, I find out that there are multiple dyes in that black marker that make it that black color. All right. I also can see that there looks like there's something that's really blue as a part of the dye that is moving faster than some other colors. Like it looks like there's a pink color down here also, and something darker in the middle. That means that this blue dye is more polar, or has a polarity closer to that of water than the other dyes that are in there. Okay, so that is our experiment for today. I'll show you something. I've done this earlier, and just to show you, you can make some kind of cool artwork out of these pieces. So this is a coffee cup filter. It's now dry. This one I just did now obviously isn't dry. But you could do some cool artwork with these. Make them, fold them up, turn them into like little paper butterflies or flowers, which is a lot of fun. But what about the other markers in your Crayola marker box? Is this blue marker? Is it really blue? You can do the same thing to find out whether or not it's blue. What about another type of black marker, like this dry erase black marker? Will it separate out the same way? And lastly, what if I don't use water? What if I use something else like vinegar, right? And I use the same black dry erase marker, I'm sorry, washable marker, will it separate out like it has with the water? These are some further experiments that you can try at home on your own and have fun with this. All right, that is our lesson for today. I hope you enjoyed it.